So has anybody had an attempt at either of these questions? Yeah? I think these are slightly more tricky, so I'm going to talk you through them, okay? Because I appreciate it was a little bit of time ago since we last looked at this. We may not have all seen it as well. So yeah, let's talk through this. So what I'm asking you to do is find the equation of the tangent. Now pause for a second. Remind me what the tangent line is.
The one that touches the curve with 1 point.
Exactly. So in other words, I have a cubic curve here. In fact, I can make a quick sketch of it. It's going to look something like this. You happy? Okay. And I'm asking you to find the equation of the tangent line. Remember, the tangent line just touches the curve. If you like, they're the zombies on the roller coaster. Imagine this is a roller coaster. The direction of the arms, which the zombies are facing, is the direction of the tangent line. Okay. And I'm asking you to do that at x equals 1. So I don't know where x equals 1 on this curve. I mean, I could work it out. But let's just suppose x equals 1 is over here. Okay. So therefore, I'm asking you to find the equation of that line there. Now, are you happy that a tangent is just a straight line? So what I'm literally asking you to do here, don't think about it as a tangent, think about it as a straight line. I'm literally just asking you, can you find the equation of a straight line? Can I ask you to find the equation of a straight line? And we know how to do that, don't we? Don't we? Good. What two pieces of information do I need if I want to find the equation of a straight line? Good, so I need the gradient. Somebody else, what other piece of information do I need?
The y-intercept.
The y-intercept would be absolutely lovely, but if I couldn't get it, what could I get away with?
B.
Sorry? Yeah, any point that lies on the line. Because from there, I'm able to work out what the y-intercept is, okay? So I just need a gradient, and I just need a point. So let's start here. How could I find a point which lies on the line? Good. So I kind of got half a point here. I found my x coordinate. I just need to find my y coordinate as well. So to find my y coordinate, I need an equation which links my x's to my y's. That's what that does. It just simply says my y coordinate is 8 times the cube of my x coordinate minus 4 times my x coordinate plus 3. Okay? So if x equals 1, then are you happy that y is going to be equal to 8 times 1 cubed minus 4 times 1 plus 3. I've literally just stuck x equals 1 into there. You happy with that? Okay. So what does this equal? 7. Perfect. So there you go. I've got a point which lies on the line. It is 1, 7. 1, 7. You all happy with how we found that? Tiffany? Good. Okay, gradient then. How could I find my gradient? Yeah, exactly. The only way to find my gradient is to do exactly what I was doing over here. Yeah? This differentiation literally finds me the gradient of any curve, including lines, right? So if I differentiate this thing, let's do it. Yeah, let's do it here. Okay. If I differentiate this thing, what do I get? Like that? Yeah. Good. Now, is this enough? Does this give me my gradient now?
No, do we need to put the x?
Absolutely. Remember, this is my gradient function. It literally says, you're not finished yet. You need to tell me which point you need to find the gradient at. Well, I know the point. It's when x equals 1. Okay? So if I go, okay, at x equals 1, stick this in here, would you be happy that my gradient is just going to be 24 times by 1 squared minus 4? Literally just stick 1 in there. Right? So what's my gradient? 20. Perfect. Okay. So there you go. I found my gradient as well. It's 20. This then is just a straightforward equation of a straight line question. Okay. So which way do you want to do it? Y minus y1 equals m times x minus x1, or y equals mx plus c? Okay, fine. So okay, y equals mx plus c. Right, let's stick it in.
Sorry, what was the first one?
This other one is y minus y1 equals m times x minus x1. Okay? If you're not sure, then go back and watch the video. Yeah. Okay, fine. How do I use that then?
We just take the points and find the c.
Exactly. So I've got a y and I've got an x from here. Got a y and x from here. Happy my y coordinate is 7. and x equals 1. And yeah, my m is there. So let's do this. So what's 7? So y is 7. So I get 7 equals m, which is 20, times by my x, which is 1, plus c. So did you work it out, Ahmed?
Yeah, 20, 7 minus 20, 7 minus 20 is negative 14. C is equal to negative 14.
Isn't it?
Oh, 13.
Negative 13. Yeah, good. So I found my c. So therefore, the equation of my straight line is what?
Y equal 20x
Yeah.
Minus 13.
Absolutely right. Absolutely right. You all happy with that? Good. Excellent. So you see this question, again, not tricky. Okay? Not tricky. It's just equations of a straight line. Okay. So this was finding the equation of a tangent. This question is trying to find the equation of a normal. What's the difference between a tangent and a normal?
Normal crosses the curve, or it just doesn't touch the curve.
Okay, so this is my tangent, the one in blue. One tangent's one in blue. Perfect. My normal is the line that comes in like that. So it's perpendicular to my tangent. Okay? So my tangent is like my zombies on my roller coaster, right? It's literally like you're going along like this, like my zombies. Okay? Normal is what normal people do on a roller coaster, like they've got their arms up in the air as they drove along. Okay. Anyway, that's how I remember it. If you want to remember it, it's just perpendicular, that's fine as well. Okay, fine. So would you be happy that we have to do pretty much exactly the same thing as we do up here, but there's one small tweak. Because we're trying to find the equation of the normal, when we go ahead and differentiate and we find our gradient, what's the relationship between the equation or the gradient of the tangent to the gradient of the normal?
When they multiply by each other, it's a negative 1.
Exactly. So in other words, when we multiply the two gradients together, it should equal negative 1. Okay? Or another way of saying that is that one gradient is the negative reciprocal of the other gradient. Okay? So basically, you do exactly the same thing, right? But the only difference is when you get here, that's not the gradient you want, you do the negative reciprocal. You happy with that? So I can go through this fairly quickly and then we can go for a break. Okay? Okay, fine. So first things first, I need to find myself a point. Well, you're happy they've been kind to me. They've already given me my point. Okay? So I've got that one in the bag. My point is 2, 2. Okay? So now all I need to do is just find my gradient. So how do I find my gradient? Yeah, good. I need to differentiate, but are you happy this is not in a form I can differentiate it in yet? So what's it going to be if I rewrite this?
8x power of negative 2.
Perfect. Now I can differentiate it. So York, what do I get if I differentiate? What do I get if I differentiate? Okay, pay attention. Somebody else, what do I get if I differentiate? Perfect. Now, are you happy? Because I'm going to end up sticking values into this, it would make sense to rewrite this. So what would this be rewritten in terms of fractions instead of negative powers?
Minus 16 over x power of 3.
You happy with that? No? Okay. All I've done is I've just rewritten this, so it's something x to the power of something. Then I differentiate it, so I bring the power down to become negative 16, reduce the power to become negative 3, and I'm like, I don't like negative powers, so I'm going to rewrite this so it's in terms of fractions. So x to the power of negative 3 should be the same as 1 over x to the power of positive 3. Okay? Literally what we're doing over there. Okay, fine. So what do I stick into this now? What do I do to stick into this to find my gradient?
The x and stuff.
Yeah, so I need to stick my x coordinate in. So what's my x?
2.
Perfect. So if I stick x equals 2 in here, what do I get? Well, negative 16 divided by 2 cubed is?
So it's 2.
Negative 2. Perfect. All happy with that? Good. Excellent. Okay, so I've got my gradient now. My gradient.
I thought the gradient we need to...
Exactly, right? This gradient here is not the gradient which I want, is it? This is the gradient of the tangent. But that's not an issue. How do I find the gradient of the normal?
It's 1 over 2.
Perfect. Okay, so the gradient which I want is equal to, well, negative of negative 2 is positive, 1 over 2. Happy with that? Okay, good. So my gradient which I'm after is a half. And then are you happy? It's literally the same thing as we're doing up here. It's now just equation of a straight line. Okay. Now one thing which I would say, because my gradient is now a fraction, I would use this one. Okay. You don't have to. You can still carry on with this one if you're fine with it. But I would use this one, and I'll show you why. Okay. So just for practice, just for a bit of variety, let's show you how to use this one. So I'm going to use y minus y1 equals m times x minus x1. All right, fine. So the y1 and the x1, that's where I stick my x and y coordinates. So the y1 and the x1. So in other words, I get y minus my y1, which is 2, okay, is equal to, and then I'll just skip the m for the time being, x minus my x1, which is 2. So the x1 and the y1, that's where I stick my x and y coordinates. Then I just need to put my gradient here, which is 1/2. Are you all happy with that? Yeah. Okay, good. So the reason why I prefer to use this one is because now I don't need to worry about this half too much, because I could just multiply both sides by 2. Okay, so I'd end up with 2y minus 4 equals 1 times by x minus 2. You all happy with that? Literally just multiply both sides by 2. So this gets multiplied by 2, this gets multiplied by 2, and this entire right-hand side gets multiplied by 2 as well. Okay, and now it just becomes 2y minus 4 equals x minus 2. Okay. Let's imagine in the question it asks you to leave it in the form ax plus by plus c equals 0. Okay, so that's the form I'm after. This is really easy to get now because all I need to do is take the x and a 2 on the other side. So in other words, I can say that the equation of my straight line is 2y minus x, and then if I take that on that side, it becomes minus 2. Is that okay?
So we can write it in that form, and we can write it in
Absolutely. If it doesn't specify, you can leave it in either y equals mx plus c or in this general form. Okay, this general form. Okay.
If it's when it specifies, it says leave it in this form, like y equals mx plus c. Okay.
Yeah, exactly. So it will always specify if it wants you to leave it in a particular form. If it doesn't specify, it's up to you. It's up to you. Okay. But I would argue that if it asks you to leave it in this form, which is called general form, use y minus y1 equals m times x minus x1. Okay. If you didn't follow that, that's fine. It will still get the same answer out with y equals mx plus c.